Hey everybody, thanks so much for having me. It's a real pleasure to be here. And hopefully you weren't out too late, so you'll bear with me as I give you a bit of context on what customers have been doing with streaming on AWS, how they started, how we got into it, what they're doing today, and where we're going. So to give you a bit of history on where we've come from, so typically, pretty much all of our innovation at AWS starts with our customers. So we talk to our customers what they need, we learn from them about the problems that we're trying to solve, and then we work backwards from there to try and figure out what we can build for them to help them be successful. And so we've been in streaming for a while. If you look in 2013, we launched our first fully managed streaming service. This is Kinesis Data Stream. So the idea here is that you would stream data at EC2 instances in Kinesis, the service, and then run custom connectors that would pull data off those streams and then fan them out to wherever you wanted to go. In 2014, we launched AWS Lambda. So this is really for event-driven computing, and customers would use it to trigger functions based on what they saw in their Kinesis streams. And we've continued to iterate from there. And so we added support for Kinesis Data Firehose. This is to simplify it and provide auto-scaling streaming. And then we added Flink to EMR, which is our Hadoop and Spark service, in 2016. And then in 2018, we added support for Apache Flink as part of our Kinesis Data Analytics service. So the idea here is this is a fully managed service. Developers don't have to think about infrastructure. It will scale. It'll provide durability, and you can focus on running your applications. And then we've continued to iterate. We have done video streaming. We're now got over 50 features available for our customers in 22 regions worldwide. And we're continuing to iterate from here as we learn from what our customers are trying to accomplish. So the journey for streaming data at AWS actually began with an internal problem. So if you think about it today, AWS has millions of customers, and they're using multiples of that in terms of resources, and these are generating real-time usage records that we have to use to compute our customers' bills. And as we scale and workloads scale, it turns out customers don't really want to spend longer waiting for their bills to be calculated. They want us to scale the infrastructure to handle that. And so that was the genesis of Kinesis Data Streams, essentially low latency, continuous streaming. We would automatically replicate it across 3 availability zones. These are independent regions and data centers within a region for providing durability and availability. And it would easy and cost-effective to scale. And when we talked to customers, they had similar challenges, and we made this service available as an external service for our customers. And then as we got going, customers asked for this capability as a service, and we were also looking not just for billing records, but we were looking to provide real-time log streaming to Amazon CloudWatch, which is creatively named, and you can imagine it's a service for monitoring your cloud resources. And this is all infrastructure that we use in-house, but we make the same infrastructure available to our customers. And so our early customers, as you can imagine, typically had a Java background. They potentially had one application processing tens of millions of daily events, and delivering data into their data lakes and data warehouses was a super common use case for them. And then larger customers had much more experience with Hadoop, and they were looking at getting real-time event processing running on their distributed clusters. And very few customers were really at the stage where they were looking at real-time analytics. And typically, these larger customers were using multiple applications, dealing with billions of events per day, and looking at advanced ETL and manipulation, and then also trying to stream data changes out of databases, with the most common being DynamoDB, which is a key value data store we developed at Amazon. And our customers look like this. So Supercell, real-time gaming event data streaming into S3, S3 is our storage service, so typically the resting point for real-time clickstream or in-game events. AdRoll, doing large-scale ad delivery online, so tens of billions of events per day, and very low latency response requirements. And then Hearst was an early customer that was actually breaking the mold and was thinking about real-time analytics early on. And what Hearst was doing is online media and mobile app consumed media. And so they're looking at real-time events to try and personalize subsequent sessions to drive up engagement. And more engagement translates to better monetization for them. And they also built real-time dashboards for trending so they could see what's getting popular and how they can capitalize on that for their online audiences and mobile audiences. So Supercell, if you've ever played Clash of Clans, they're the company that make that. And it began with classic batch-oriented architecture, moved to streaming, and they were initially using Kinesis and S3 and moving that data into their analytics. And they've been one of the earliest customers on Kinesis and have been using it regularly since they got on board. And if you think about Supercell's data pipeline around 2012, it looks like what many customers are doing at that time. You've got a mobile app talking to an app server, something is aggregating client events and then writing it out to S3 where it goes into data lakes and is then used for analytics or machine learning, typically offline and batched. And customers we were finding were not keeping as much data as they could, simply because of cost and hassles in dealing with data collection at scale. And then as they evolved, this evolution will be similar to what many of our other customers have gone through, is essentially you still have your apps and your app server, you have an event collector, but you also have server event collectors. And then you can feed this data in real time into Kinesis. And Kinesis is designed for low cost and high scale, and then you can fan this out into multiple different consuming applications on the stream. So you start to see real-time analytics, machine learning, and then you also still see the batch and compression of data going into S3, where customers are running their analytics and their machine learning jobs. And just for context, you could probably fire all of Twitter at Kinesis, so 500 million tweets a day for less than 50 cents an hour. So really designed to scale up when you need it, scale back down when you don't. And as we saw, just like every customer, Supercell was building delivery apps. They wanted event delivery into data lakes, into their data warehousing infrastructure, and so we decided to build a service to make this particular piece of the pipeline straightforward. And so Kinesis Data Firehose is really designed to be an easy abstraction on top of Kinesis Streams that enables autoscaling and automatic delivery of data into either a data warehouse table where it can be kept in sync in near real time, or it can actually aggregate events, convert them to an open source format like Parquet, and then write them out in partitions to S3, so you can have streaming delivery right into your data lake, and then that's available for any downstream analytics you might do. And you can stream data from Firehose into S3, Elasticsearch, or Splunk, so you can get that real-time operational event analytics as well. And then as we continue to iterate with our customers, we got a lot of feedback about needing to make more advanced real-time analytic use cases available. And Supercell, again, was leading the way, but along with many other customers. And at this point, we chose to offer a fully managed experience with Apache Flink. And so this is Kinesis Data Analytics for Flink. The idea was that Java developers can write their analytic applications, have really high-quality streaming abstractions and APIs underneath. And some of the key drivers for this were, initially we started with SQL, but customers wanted a procedural abstraction, so something like Java. And then as we heard from some of our cutting-edge customers that were pushing the boundaries of what was possible, Flink really opened up new use cases for them for high-quality streaming. And the easy-to-use APIs in the language, the low latency, and then the exactly once semantics made it a lot easier for them to reason about streaming applications. And this is what drove us to offer a managed service. And so the idea here is that essentially you can declare what you need in terms of infrastructure, you can focus on your application, and the service takes care of scaling up and down and managing your security and connectivity. Again, letting customers and developers focus on the parts of their app that matter and not on running infrastructure at scale. And so we see a number of ways to run Flink at AWS. You've got the managed service, Kinesis data analytics for Java. You've got EMR, the ability to essentially load Flink onto Hadoop and Spark clusters. We manage taking care of cluster scaling, provisioning, auto-scaling, but customers are really configuring the application, configuring Flink, and then running their own apps. And then on EKS, our Kubernetes service, customers are also running Flink at scale using Kubernetes operators there. And really, we see a diverse set of use cases. It ranges from gaming. We'll talk about some of our internal cases. We've also got examples of financial services companies and hedge funds looking at real-time event processing based on market signals. It's really a diverse set of applications and a testament to the flexibility of the APIs that Flink provides. So talking about where we are with streaming data on AWS today. So our customers have evolved. Delivery is not the sole use case now. We see less than 40% of apps being purely focused on delivery. We're seeing a lot more real-time analytics, and customers typically have expanded their usage. Now they're running 3 or more applications. They're interacting with typically 3 databases. We're seeing things like DynamoDB streaming data out into Flink applications. And then Flink on AWS is actually growing faster than any of our other stream processing models. So we're seeing this as one of the fastest growing techniques for customers who are doing stream processing at scale. And we'll continue to be iterating here as we listen to customers about what they're trying to accomplish. And today, customers are using a combination of stream capabilities in Flink. We're finding that half of our customers are still net new to streaming. Just a quick show of hands, how many people have yet to write their first production Flink application or are new to Flink? Yeah, it's a reasonable amount, so that's great. And customers are processing hundreds of millions of events per day. And then with large customers, we're seeing many more use cases, the use of SQL in addition to Java and Python, and they've got tens of applications dealing with billions of events per day. And then our largest customers are essentially using Flink as a platform and as a key component of underlying infrastructure that they provide to their developers. So essentially, they've built internal abstractions and APIs on top of our managed services, and then use that to offer internal APIs to their customers. And so these abstracted platforms might have thousands of applications processing trillions of events per day. So really high scale use cases and spanning the board, and we only see this growing. One of the things that we've noticed at AWS is that, as I'm sure all of you are aware, data volumes are expanding rapidly. We're seeing about a 10x growth every 5 years. So in 10 years' time, customers are going to be dealing with 100 times more data than they are today. And as we move into this world of real-time, always-on connectivity, as we move further into it, the need to process data in near real time will only continue to go up. So this is a huge growth area, we believe, for AWS and the community as a whole. So just to talk a little bit about where streaming is used within AWS, we already talked about billing. Amazon S3, one of our largest services, this provides events on data arrival, and customers are using that to build event-driven applications and streaming applications. We're streaming data in near real time directly into CloudWatch logs, and then customers can set alarms and alerts based on that to take actions in their environment. We're using streaming extensively in the Amazon.com e-commerce business, so both catalog, clickstream, transaction streams. These are all key parts of Amazon.com infrastructure. And then I don't know if you've ever had the chance to go to an Amazon Go store. But these are stores where you walk in, you have an app, you scan the app, you pick up stuff and put it in your bag and walk out. It's a very cool experience, but I don't recommend it as your kid's first introduction to shopping. It will lead to problems down the road. But there as well, we're streaming data in real time and making decisions about what people are putting into their bags and walking out the store with so that we can charge them. And then our customers are running a wide variety of use cases in streaming. So Zynga is real-time in-game analytics. Atlassian is looking at how people are using their SaaS applications. Sonos is connected devices. If you're in the States and use Zillow, essentially all of the data that's streaming in about real estate transactions, user-submitted reviews, user-submitted imagery, all of that is going into essentially updating home price estimates in near real time. GE is using streaming for predictive analytics and IoT and large factory equipment. And then Lyft, who spoke yesterday, I believe you heard about how they're using streaming throughout their infrastructure. And I'll talk a little bit about Autodesk and what they're doing as well. So Autodesk provides 3D design software, CAD, tooling, and essentially they're moving to getting real-time telemetry on how customers are using their applications to provide a better customer experience. So all of this is streaming data, and they're using it to understand what features people care about, whether people are having a bad experience with their products, and what they can do to improve the overall customer experience. And so conceptually, this is how Autodesk runs its streaming architecture. So essentially, they're ingesting log data in near real time from their applications running on EC2, running on ECS, which is our container service, and then events coming off of AWS Lambda. This then goes into the Kinesis data stream service, and then from there, it's fanned out in a couple of different ways. They use Firehose, our auto-scaling Elastic easy streaming delivery service to deliver events to Elasticsearch and to deliver events to Athena. Athena is a serverless SQL on S3, so you can run SQL queries directly on your data in S3. And then they're using Kinesis Analytics to generate custom metrics, and those go into CloudWatch. And in CloudWatch, they can then generate alarms and triggers that can take action. So, for example, if a particular feature latency is out of band, you can fire an alert, and then somebody can trigger a workflow that can lead to going to go and fix that. And there's a couple of patterns here which are important. So one is that you can essentially decouple your stream collection from your stream processing. So these can scale independently. So if you have a spike of usage, you could scale up your streaming layer on Kinesis data streams. And then you can choose to optionally scale up your processing layer on Kinesis data for analytics. But this gives you the ability to essentially have each component in your application independently scaled. And this is generally a best practice for how we think about application development on AWS. You want loosely coupled APIs so that different portions of your application can scale up and down independently from the others. We also use Flink extensively in AWS data center operations. So we have our data center services group. If you think about it, we have 22 regions across the world, multiple more edge locations, and each of those contain data centers with servers and switching and power and cooling. And so we're using Flink to essentially get all of this data into our application so we can monitor our data center environments so that we can deliver high quality availability for our customers. And so what we're doing is low latency processing of gigabytes per second of data. And then we're taking advantage of Flink's windowing capabilities to join data from multiple data sources. And we also benefit from the ability to deal with out-of-order data automatically, thanks to the semantics in Flink, and the ability to recover from missing data or to backfill. So this creates a really powerful way for us to keep an eye on what's happening in our environments. And therefore, we can correctly monitor these systems. And so the architecture here is relatively similar. We've got data coming off of DynamoDB. That data is going into our Kinesis data analytics application. And then we're making that available for event storage in S3, data warehousing for low latency reporting in Redshift, and then ad hoc analytics on S3. And so we capture data across all of our servers, physical topologies, our networking, and we do things like track the drift on the settings for cooling, just to keep an eye on every element in our environment that could create a problem for customers if it goes wrong. And we also use this to feed into autonomous control of our cooling and power systems to make sure that we're operating within the right parameters for the equipment in those data centers. And then in terms of what things are going to look like in the future, so we're really focused on trying to think about ease of use. I know that's a big priority for all of you as well, but ultimately we don't believe that most developers will really care if they're using Flink or some other streaming data service. They really want it to be able to be easy to express the applications they want to express and not have to worry about the underlying infrastructure. And so a typical large customer will have teams across the company that vary in sophistication. Some people will want to be able to get into the details. Others will just want to consume services. And then at the platform level, these large-scale customers, they'll have deep experts, but they're going to look to make streaming available to the broad application developer population as well. So I think an opportunity for all of us is to really make this simpler for customers to take a look at and to consume. And then, Flink in the future, I think for us at AWS, we see Flink as really the fastest growing framework for dealing with streaming data at AWS. It's just growing much faster than any of the other models that we have. And while the usage is still relatively small and it's still early days for Flink, we're excited about the trajectory that it's on and the growth that we see. And we're also very keen to work with all of you in the community to help grow this framework in adoption and make it more widespread. It's a really exciting time to be part of this, and we're very much looking forward to partnering with all of you to help grow this in our customer base and ultimately to help customers solve the kinds of problems they're trying to tackle with streaming data. And then we have a saying at AWS, it's still day one. And so while we've been at streaming for a long time, we do believe that it is still day one. We're just getting started on this journey with all of you. And we're excited to go down this road together and see what we can build and see what problems we can solve on behalf of our customers. So thank you very much for having me. Really appreciate it.